10-meter data is great for low-level scenes like the main camera view, but what about aerial flybys higher up? We don't need the extra terrain detail and render time cost that comes with the higher resolution terrain. 90-meter data would be more than adequate for such an application. We could download and import USGS 90-meter data, but we already have a single 10-meter DEM that we can import and resample at whatever resolution we choose. Launch the Import Wizard and select the original 10-meter DEM right there at the end of the list, ynp-10m.elev. The Import Wizard will correctly identify it as a WCS VNS DEM. And let's go twice with the next to the Output File Type and Name window. Change the name to ynp-100m. Twice more to the Data Positioning page and change settings. Keep going until you get to the last Output DEMS page. And here we're going to change the output columns and output rows to values such that we will get 100 meters as the cell size. To do that, easy enough, just remove the last digit from the output rows and columns. That will reduce by a factor of 10. And once those update, you will see we have about 100 meters on the west-east and north-south cell size. Import the data. Won't take very long at all. And you might have noticed in the real-time plan view there was a shift in the terrain as that DEM was imported. Find that DEM in your database editor. Should be at the top of the list. Click on it, and you'll notice the real-time plan view as a little wacky. That's because we have the 100-meter DEM covering the same area as the 10-meter DEMs. Again, we have an overlap. We have a different coloring here because the resolution of that 100-meter DEM is much lower than the 10-meter DEMs. Let's see how that 100-meter DEM compares to 10-meter DEMs. Select any 10-meter DEM. Select the DEM 10M layer and disable. Open another main camera view in place of the plan. Save the project. Render preview. The lower resolution DEM renders much faster and with an obviously lower level of terrain detail.